Hello students. Today we are going ahead with the next part of the Scilab practical, that is our lab 3 session. In lab 3 we have to see the bisection method, regular policy method and the Newton-Raphson method. These three methods which we have to see. So I'll just go for bisection method. So we'll have this program with us. So you can see here that the So you can see here I have written the program for bisection method. So this bisection method is nothing but you have to calculate it for some function root, correct, by using the method. Now this is applicable for transcendental as well as algebraic equations. So here you can see that I have written a function. The function is what? Y equal to fx. We are writing this as y equal to fx and I will declare that function. Which function I have taken? X raised to 4 plus 2x cube minus x minus 1. Now this problem we have done it. So I have taken that function. So it is x raised to 4. How you write in code? So you have to take x hat 4 means x raised to 4. Either you take it this way or you can write multiplication of x 4 times. X into x into x into x. Correct? Plus 2 times x cube and minus x minus 1, and then you give the end function. Now what is the next requirement? We require the interval in which the root lies. So you have to ask the user to enter that interval. So here we just take a is equal to input the first interval, that is first value of the interval. So I've written that comment. Then next is b is what? Input the second part of the interval, that is b. A to b we are writing. Suppose it is 0 to 1, then I have to enter a as 0 and b as 1. Then n is equal to input the number of iterations, correct? We have to enter the number of iterations there. So now after taking this, what is the next part, important part, that is I have to perform those many iterations. So we'll take help of for loop. So for I equal to 1 colon n means how many iterations we want? We want n number of iterations. Therefore for I equal to 1 is what? 1 is the starting point and up to n, correct? So those many iterations I want to perform, and c is equal to what? C is equal to a plus b by 2 here. C is a plus b by 2 that we have seen. So you have to write it down properly. Now what is the next condition? If f of a star f of c is less than 0. That is the half part of this. If function values, the product is less than 0. That is one is positive, one is negative. Then the product is going to be negative. So then b is what? B will take the value of c. And the new interval is what? A to b. Correct. Now next is else a is equal to c. Means what? Fp star Fc is less than 0, correct? So that means A will take the value of C. So we'll end this loop and I want to display the iteration number with the root, and then we'll end this for loop. We'll end this for loop. So what we'll do is we just this as saved it as bisection.sci, and now what I'll do is I just save and execute this. Now after saving and executing this, you can see here we can see that here on the console. Let's just share this console now. So here it is asking that you have to enter the value of a. So we'll enter that value of a as 0, correct? And then you enter the value of b. B is 1, okay, and enter the number of iterations. Suppose I'll give the 30 number of iterations. See, while performing manually we have to think about these many iterations, but here you can give it like that. And see, you can see that after say 30th iteration the value is exactly same. See, till what we have the different values till 22, correct? And up to how many decimal places? 1 2 3 4 5 6 7. So we are calculating the actual value up to 7 decimal places. You can see here 7 decimal places, and that is the beauty of this programming. Okay, beauty of this programming. You can see that all this iteration wise we have calculated the values, and we have performed it so well that we are getting the values up to how many iterations are required to get up to 7th iteration. So you can see here that is 24th iteration is same as 23rd iteration. So we must stop at 23rd iteration only. Correct. We must stop at 23rd iteration only. So here you can perform those many iterations. Okay. So this ends with the bisection method. This ends with bisection method.